Global illumination is a simulation of all light interreflection in a scene. So an example of global illumination would be a room with all the lights turned off, but it's still illuminated by that outside light that might be coming through the windows. Now, global illumination can't be simulated with standard ray tracing methods, so we use a method based on photon maps. And we won't be able to use a Maya software renderer to do this, but rather the mental ray from Maya renderer. So we're going to access that by going under Window, Rendering Editors, Render Globals. And just make sure that the render you're using is set to mental ray. So in order to get global illumination, we're going to use mental ray. So as I mentioned before, we need to use something called photon maps. Now what happens is light is emitted in the form of energy called photons, and these bounce around the scene and we follow them around a scene until they're either absorbed or they escape into infinity. Now these photons are then stored in the photon map and then used at render time to calculate illumination. So this generation of the photon and photon maps is actually done before render time. So let's just look at a quick example of global illumination. In this scene, what I've got is basically it's a bike and it's within a cube, and then I've opened one side of the cube and I've basically shot some photons into the scene, and we'll show you how to do that. But it's kind of like this spilling of light into a garage, for instance. Okay, so there's no actually direct light in this scene. It's all based on photons. So these, these energies that are bouncing around the objects in the cube. Okay, so that's global illumination, and so let's look at how we can set that up. Just going to stop that. Now, the first thing we're going to want to make sure is that we have the mental ray from Maya renderer selected. So we'll just go into render using under the render global setting and just choose mental ray. Now, because we are setting up global illumination, one of the first things that we're going to want to do is go into the mental ray tab and just under quality, just make sure that preview global illumination is selected. Okay, there's a number of presets here that you can choose from, but since we are setting up global illumination, choose this guy here. The next thing that we're going to want to do is make sure that we have some kind of light source that's emitting photons. So I've chosen a spotlight, and I've set up the spotlight so that it encompasses the cube and also the sphere. So if we just go to look through selected, you can see the cone of the spotlight here. It's encompassing that cube and the sphere. So what's going to happen is I'm going to shoot photons out in this direction into the cube. They're going to bounce around the cube and the sphere and then create a photon map, which will later be used to calculate the total illumination of the scene. So let's just go back to the perspective here. And the first thing I'm going to do is I'm just going to do a render. So just so that we can compare the difference between a direct illumination, which is what we have here, and indirect illumination, which is the global illumination. So the first thing I'm going to do is change the intensity from 1 to 0. So this light is not illuminating the scene with direct light. And then the next thing I'm going to do is just turn on emit photons here. Okay, so just under the mental ray section under caustics and global illumination, and let's go ahead and do a render. Now you probably can't see that, so obviously we aren't getting enough brightness in the scene. So in order to increase the brightness of the scene for the global illumination, we're going to need to increase the RGB values for the energy. So let's try a value of, let's try 15. So we'll go 15,000. And let's go ahead and try that. So we might want to save that and just do a comparison. Okay, it's a little bit brighter, but you may want to go ahead and increase that even more. This is usually the first step that I do, is just figure out the brightness of the scene and then do any kind of adjustments later on. And let's try that. Okay, so 25,000, that looks pretty good. We may even want to make that 30,000. Let's try 30,000. Whoops. And so on. What the exponent does is it acts like a decay. So it decays the intensity as this value decreases. So an exponent of 1, the decay of the energy is going to be a lot less than if it's at 2 or 3. So it's basically the intensity is equal to 1 over the distance squared. So the higher the value, the faster the fall off of the energy. So this looks pretty good. You know, we're using about 30,000, a value of 30,000 for the energy. But you'll notice, if we just kind of come in here, we're getting some nice kind of color bleed in the area from the sphere onto the back walls and the floor. But you notice that we're getting these kind of splotchy patterns. So what we might want to do is adjust those by adjusting things like the radius and the accuracy in the render globals. So let's go to the render globals. And just under the caustics and global illumination section, we're going to try adjusting the global illumination radius and then increase the accuracy. So if I just make this a value of 1, see what that does. Okay, so that didn't really do too much. We're still getting the blotchiness. Let's go to a value of 2. Just going to save that. Okay, and you can kind of see that that value of 2 for the radius is getting rid of that kind of blotchiness. There's a value of 2. There's a value of 1. I'm going to go a little bit higher. Let's try a value of 3. Or excuse me. And let's do, save that. Okay, so let's compare those. Now it doesn't look like there's much difference between the 2 and the 3 there. Definitely a difference between the 2 and the 1. So a good or a good rule of thumb is to increase the radius until you really don't see any change at all. So there's really no change between 2 and 3 at all. So now we can come in and start increasing the accuracy. So try increasing this slowly because this does tend to take a little bit longer to render when these values are higher. So let's go ahead and render that. Okay, so you can see it's starting to smooth out a lot more. You may even want to try a higher value at 200. Still not taking that long to render, but there we go. That looks pretty good. We may even want to try 300. To further increase the quality, or for better quality, we could also increase the number of photons, so the amount of photons that are actually being emitted. So right here under global illum photons, 10,000 were emitted originally. Let's try a value of about 20,000, just to see, what kind of effect that has. Save that, render that. Okay, so there's 20,000 photons. Let's bring that up full screen. And there's 10,000, so a slight difference. You may even want to increase the energy as well. It is a little bit dark in here, so you may even want to use a value of 50,000 here. So just let's look at the comparison between our direct illumination and our global illumination. So this was rendered with a direct spotlight illuminating the scene, and this is our global illumination result. So no direct illumination, just indirect illumination via the photons, and that's the difference. This has an energy value of 80,000 and an accuracy value of about 700. Caustics are a form of global illumination, and basically what they are is they're light patterns formed by focused light. So they're created when a light from a source illuminates a diffuse surface via one or more specular reflections or transmissions. So we can see this in this example. We have some nice kind of focused light around here and in the wine glass. So again, in order to get this effect, we'll need to use mental ray for Maya, and we will also need to use the photon method mapping. So that's also very easy to set up. Let's go to a file. Okay, so what I've got here is just, it's a ring and it's sitting on a plane, and it has a gold sort of metallic shader assigned to it. And if we just do a regular render, it's going to use mental ray. If we just use a regular render, this is going to be the result. We'll just save that. But if we go ahead and add caustics to this, we're going to get a much different result, a more realistic result. So let's go to the light and just make sure, okay, it's actually illuminating it, but we're going to turn on the photons as well. Okay, and I'm going to go to the render globals, and under mental ray quality, choose the preview caustics. So earlier we chose the preview global illumination. Now we're going to use the caustics. And right off the bat, we should see something. Okay, so you can see we're getting really nice sort of focused caustic highlights here. If we want that to be brighter, we can increase the energy. And same kind of thing for the global illumination. Okay, so that you can increase the accuracy, you'll catch the detail, it'll be more accurate. And then the other thing is for smoothing out the caustics, you can use one of the two filters we have. So you could use a box filter, or you can use a cone filter. And just kind of tweak those and adjust them accordingly, do some renders and see how those affect them. Okay, so let's look at what we have here. Let's bring this up full screen. It's just going to go 1-to-1. So if we just look closely in here, I'm not sure if you can see this, but this is the caustic with using our cone filter, and that's with just the box filter. So the cone filter is a little bit sort of smoother, and that's with no caustics at all. So you can see that they really do add quite a lot of realism to a render.